because you're contradicting yourself. You're saying that the ship is accelerating, right? Because he's literally saying that. He's saying the ship isn't falling, the guy is falling because he has his rockets on accelerating, just like anyone hovering above a planet would have to do if he wasn't orbiting, right? And he's saying that this accelerated frame of reference is not an accelerated frame of reference. This is an inertial frame. And the falling guy that doesn't have any rockets, he's actually the accelerated frame of reference. This is double speak, man. Come on, man. Come on.
But it's not. It jumps right out of Einstein's equations.
No.
Now you are inside the event horizon. So what happens here? Strangely, you'd actually have a pretty hard time knowing when you cross the event horizon itself. You can still look out into the universe, seeing distant stars and even seeing our ship floating out there in space. But all of that light, just like you, is entirely destined to head to the singularity now. You are past the point of no return. That point...
Yeah, the clock in the ship... If you're the spaceman at this point, if you're looking at this spaceship, the spaceship's clock, first of all, right, it's going to be slowing down because it's accelerating, right? So it's going to look like it's slower. Secondly, because space-time is basically expanding in between the two people, it's going to look like it's slower too. And because of the Doppler effect, it's going to look like it's slowing down three different ways. It's going to be looking like it's slowing down. It's not the other way. This guy is saying the other way around, man. He's saying it backwards. Why is he saying it backwards? Oh, he's woke.
Of infinite density, where our laws of physics collapse and time simply stops. To escape the pull of the singularity, you would need to travel faster than the speed of light, which we know is impossible.
Yeah, because the space-time, right, is accelerating down to the black hole, faster than the speed of light. Just like the in between galaxies, the space-time expands, right, faster than light can move. Well, in this case, it shrinks faster than light can move. Okay.
A common misconception is that if you looked out into the universe, this intense time dilation effect would cause you to watch the entire future history of the universe unfold in front of your eyes. But this is just not true. Due to an effect called aberration, as you get close to the singularity, you'll watch the outside universe get squished into this thin little ring. And finally, once you are close enough to the singularity, your feet would be stretched out in front of you, dislocating your body in a process known as spaghettification. You and the black hole are now one, wandering the universe together for eternity.
Okay, well that was Astro Boy. No, his name was ASTROKOBI, K-O-B-I. Did you see the doublespeak? Did you see the doublespeak? Oh, he's a double speaker. He's woke. He's got wokenitis. So let's review on what this guy is saying, this woke podcaster. He's got a ship, a black hole. He's got an inertial, he throws this guy out, right? We put him in a box. He didn't have him in a box. But we put the fallen guy in a box, right? Now, how is this guy, right? Let's say put this box next to the ship, right? Then they disconnect the box from the ship. Then what? The man falls, but the ship doesn't fall? Why doesn't the ship fall? See, and we know there's no orbiting because of two reasons. He said that he parked his ship there, number one. Parking means that he's not orbiting. And number two, if he was orbiting, that means this man is orbiting. And if this man is orbiting, he would not fall into the black hole. What he would do, right, because of his momentum, he would end up orbiting the black hole. But he didn't orbit the black hole, did he? Nope, he fell right into the black hole. So we know when the inertial man was let out of the aircraft was not, or the spacecraft, was not orbiting or having momentum going that way or this way, right? It just came here, right? Accelerating, then it deaccelerated. So it can, and then once it starts going the other direction, it let off of its thruster so that it just stood there and hovered, right? That's the only explanation. Is this man saying that magic, there was no thrusters, no rockets, and this spaceship just hovered there, using magic, and then he disconnected this box, right? This box would be right here connected to the ship. And the box fell, but the spaceship stayed there because of this magic. Now, if he's saying that, we know he's woke because he's using magic to describe his stuff, right? So I don't think he believes that. I think that he believes that he knows that this spaceship will fall unless he puts on its rockets and goes in the opposite direction that the space-time is pulling, or gravity is pulling him down, whatever you want to call it, right? So he's saying he knows this ship is accelerating. He knows, because otherwise it would fall along with this guy. And if it was orbiting, then neither one of them would fall in the black hole. They would orbit. But that isn't happening. That isn't the case, right? So we know he parked there. We know he put his thrusters on. We know he's accelerating, right? But this guy, this woke, lying podcaster, right, wants me to believe that this guy, this spaceship with his rockets accelerating him is an example of an inertial frame of reference. That's what he wants me to believe. And he wants you to believe it too. Why? Why would someone be so insane to think that? The guy is accelerating. He's in an accelerated frame of reference. Don't try to tell me different. You're crazy. Okay? Just like this guy. This guy isn't falling into the black hole. He isn't falling. The only one who's falling into the black hole is the guy who don't have rockets. Yeah. So if you have rockets, and that means you're accelerating. You can't just fire off your rockets for hours of time while this guy falls to the black hole, and you're like, oh well, yeah, I'm not accelerating at all. Okay. And then he has the audacity, after telling us that the rocket that has is firing his rockets, accelerating, is an inertial frame. After he has the audacity to tell us that, then he tells us this guy, who has zero rockets, is actually accelerating. He's an accelerated frame of reference. And then he tells us this. He knows that if this guy right here falling, if he was in a box like I have him in, and he let go of a ball, the ball just stands there relative to the man in the box and floats. A test to know if you're in an inertial frame. Yet he tells us it's an accelerated frame reference. And then here, we all know if this guy has his rockets on, right? If a guy was inside the ship and he dropped the ball, had a ball and he let it go, what would happen to the ball? We all know that it would fall to the freaking ground. It would accelerate to the ground because the ship is actually accelerating up, right? And it would appear that the objects were accelerating to the bottom. Is he insane? Is he insane, or is he just stupid? Or I don't understand. Is he retarded? He knows that there's a rocket on here. He knows this is accelerating, and yet he actually has the balls to tell me that it's not an accelerated frame of reference, and there's no time dilation. But this guy who has no rockets, he's in an accelerated frame of reference, and that's why he gets time dilation. This makes no sense. None. The way I say it, it makes perfect sense. This guy, right, you can see on the geodesic that the further away the geodesics are, just like over here, further away the geodesics are, look at the acceleration. The geodesics get closer, look at the acceleration, it gets bigger. Put it here, the acceleration's even more. The more and more, the closer the geodesics are, the more you're going to be accelerated, right? And that's why over here, he has to accelerate more than this guy because space-time is accelerating downward, right? Accelerating down, so he has to accelerate the same exact way, but in an opposite direction. Same with this guy. And that's why he gets time dilated more than, that's why this guy gets time dilated more than this guy, because he's accelerating more to overcome the geodesic more than this guy is accelerating to overcome the geodesic. They'll get more time dilation here, less time dilation here, and zero time dilation here. It only makes sense that way. It doesn't make sense any other way. Okay? The clocks in the inertial frame are going fast, just normal rate. This guy is time dilated, and this guy is even more time dilated. To say otherwise, because basically these guys are on the hill, and this guy is on the flatland. Right?
So if he's on the flat land, right, on his little buggy with wheels, he's not moving. He's inertial. This guy here on the hill, on the curved space, he's going to fall down if he doesn't accelerate. So for him to stand still, he has to be accelerating. For him to stand still, he has to be accelerating. For him to stand still, he has to be accelerating. But relative to space-time, these two with the rockets, they are accelerating relative to space-time. This guy is standing still relative to space-time. And that's all that matters when it comes to what frame of reference you are in. Okay? It's that simple. This guy's traveling a straight line geodesic. He's constant velocity. This guy, if these guys let off of their rockets, right, and just started falling, we would all agree that at that point they would be traveling a straight line, right, a geodesic straight line, and they would be traveling a constant speed, right, through their straight line. They would have a constant speed, zero acceleration, right? The only reason he can, when he turns on his rockets, he deviates from that geodesic. This guy doesn't deviate. He just follows the geodesic. This guy is deviating. He's doing this. He's traveling this rocket, right? He's traveling this black dotted line. He's deviating from the straight line. He's not traveling a straight line. So therefore he's accelerating. What is so hard about this?